Solar energy is what drives the future. This is what scientists are hoping for and what private investors are rooting for. To make this eco-dream happen, it's crucial to develop more and more sustainable and efficient technology. At the National Institute of Material Physics in Romania, researcher Ioana Pintilie and her team are working round the clock to design new solar cells and photovoltaic modules. The focus is to reduce production costs while keeping the product environmental friendly. In order to develop cost-effective technology with a low carbon footprint, it's crucial to reduce to a minimum the pollutants during the fabrication process. Stay tuned to find out how new solar cells like perovskite are conceived.
What is the opportunity of your project in the actual climate context?
One of the major challenges for the humanity these days is to find the ways to fight against the climate change, and for this, one way is to succeed to generate electricity from renewable energy sources. The sun is obvious, the most abundant and safe source of energy on Earth, and above all is also supplied free of any cost. So our aim or our goal is to find efficient way to harvest this energy. One way to do it is to convert the solar energy in electricity. For example, 1 hour of sunlight on Earth generate electricity more than we use nowadays in a year. So the trick is how to manage, how to harvest the solar energy. As I said, one way is to transform it in electricity, and this can be done via the photovoltaic effect. However, in order to implement the photovoltaic technology on a large scale, it has to be cheap and environmentally friendly. Currently, the crystalline silicon and thin film technologies are controlling, let's say, the photovoltaics market. However, in the manufacturing process of this kind of solar cells are used high vacuum or high temperature procedures, and this leads to a large consumption of energy and finally to high costs of production. On the other hand, recently it was discovered, let's say, an emerging photovoltaic technology that is low cost and high efficient, and this is based on another class of materials called halide perovskites. The research done on this type of solar cells had proved actually that they can have high conversion efficiencies. The research was done in laboratories on small area devices. However, of course, in order to enter in the production, one has to scale up the technology from small area to large area. And in this respect, this is what we do, and our project is dealing with such challenge.
Can you provide a few more details about the project and maybe show us how it does actually works, what you do
yes.
here?
First of all, I have to say that our project addresses some important challenges that has to be addressed prior to any attempt of industrial fabrication. And that is, for example, to develop printing technologies suitable for large area production, and in the same time to reduce the toxic elements, whatever are used in the fabrication process. And I can show you, for example, these are some small area solar cells produced in a lab, in the laboratory with some specific technique which is normally employed by researchers in the lab. But this technology cannot be scaled up to large production. For passing from from small area to large area, as you can see here, We need to develop other technologies, other procedures of fabrication that can be readily, let's say, transferred to industrial production. And in this class of technologies are the printing technologies. Here I have to mention that in the structure of perovskite solar cells, there are three different types of materials in the structure of a cell. So one has to succeed printing all these different materials. And we did this. One of the layers is deposited with a spray coating technique, which was developed in-house, and I will show you in another lab where that kind of deposition is performed.
So this is the large area for the titanium dioxide deposition. So here we can see the dispersion of the titanium dioxide. Madame Pintilie explained what it does. And it's computer controlled, so we can move it any direction we want. And now I'm going to just start it to show you how it's done. So we're just using a gas to draw the solution through a nozzle and spray the solution on the heated substrate. And right now it goes back and forth to do multiple passes on the plates. It's the dispersion is in alcohol, so it rapidly evaporates and leaves the material on the surface with a continuous film. So right now we're doing 15 layers. And as you can see, the computer is doing all the work for us. And this is very good because we can very easily deposit the same layer at the same conditions. And also for industry, obviously the system is very compatible with any industrial production systems. And this is the last layer, and after this, it will go into a kiln to completely burn off all the organic matter and form the compact and the mesoporous film, the titanium dioxide film.
We will look to the layers that was just deposited by that spray deposition technique. It's a mesoporous layer of titanium dioxide, and once you can see, it's really a bit porous, and this helps very much in anchoring the next layer in a perovskite solar cell, the one that is got black using the other printing technique. And the other two layers are deposited by a slot die procedure. So in principle, we use some solutions. They are transparent at the beginning, but once the technology of deposition and some small treatment is done, will become black, and this actually shows that these materials are good photovoltaic materials. Once you go to large-scale production, you have to be very careful of the solvents and anti-solvents you use, because usually they are highly toxic. It's the same procedure, let's say, like, or the same challenge like for electronic industry. One important step we succeed to skip, let's say, is to completely eliminate a very toxic anti-solvent treatment that is usually done in when you prepare a small area perovskite solar cells.
So this is one of the findings in your project. Are there any other partial findings so far?
Yes. So I have to say that in order to be able to develop a proper technology, then you need first to understand the physical working processes that takes place in such structures and materials. And only based on this fundamental research, you can then find the proper material and solvent engineering solution for reaching actually the performance as required by the market. In this respect, So although our contribution is important in eliminating, let's say, some toxic chemicals, there are still problems in stabilizing the device performance. And we are still working on it, and most likely is a research which will continue further after this project. The next steps would be to try to increase and to stabilize the performance you get after fabrication.
Your project involves collaboration with a diverse team of researchers and an international partnership with esteemed institutions like University of Oslo, Reykjavik University. What advantages or benefits does these partnerships bring for your project and your team?
This international cooperation with prestigious universities from Norway and Iceland, first of all, ensured the needed complementarities in the project such that we can reach the goals we proposed at first. And this is especially important because complementarities were related both to expertise and infrastructure. So together we achieved a remarkable knowledge about fabrication of this kind of perovskite solar cells and paved the way towards, let's say, industrial fabrication. Very important for us was that our common scientific research is highly appreciated in the field. It generated already hundreds of citations and many of them in top 10 worldwide scientific journals. And that obviously led to an increase of visibility of Romanian research and nevertheless sort of paved the way to further active participation of Romania in the European research area, especially in this field of photovoltaics and developments in material science.
What do you think would be the social impact of your project?
In general, the photovoltaics thematics has a strong social impact. First of all, because after you fabricate the photovoltaic panels, they do not produce any noise, no toxic gases emission or greenhouse gases. So it's a zero emission process of converting the solar energy into electricity. However, during the fabrication process of the panels there are used toxic solvents, and reduction of their amount is also one of the objectives of our project. And as I mentioned before, at least one very toxic step was eliminated already.
What would you like people who watch this interview remember about your project?
Romanian researchers, yes, put their energy in trying to solve one of the major problems of humanity nowadays, to develop photovoltaics technologies that can be implemented on large area on Earth. In this respect, we are deeply in debt to the donor countries, which find a nice way to promote and actually substantially financially supporting the international collaboration based on the idea working together for a green, competitive and inclusive Europe.
Thank you for watching Research in the Spotlight, a podcast for scientists and passionate science people made under the EEA Grants Research Programme by the Executive Agency for Higher Education, Research, Development and Innovation Funding as program operator. Until the next time, like and share this episode if you think science is our key to a better future.